Today's lecture we are going to see the topic simulation and modeling for mechatronics. The subject code is Bmt702. Course delivered by M.Chandra Mohan, Assistant Professor, Department of Mechatronics, Bharat Institute of Higher Education and Research, BIST, Chennai. In this lecture, you are going to see about the first unit. In first unit, you are going to see about what is a system and the system environment, and what are the example for simulation and why, where simulation will be used. First of all, we will be seeing what is a simulation. Simulation is the imitation of the operation of a real world process or system over time. And next is why simulation is a non-appropriate tool. You know that simulation will not be conducted if it is a simulation, the problem is able to solve by a common sense. Next one, if the simulation is not be performed, when the problem can be solved analytically. And next, if it is conducted by a direct experiment, the simulation will not be made. And next one, if it is exceeding your saving of your project, simulation will not be done. And next one, what are the applications of simulation? In applications of simulation, we have 7 numbers. One is in manufacturing industries, also we are using simulation. And next one is construction engineering, military applications, semiconductor applications, logistics, transportation and distribution applications, and business process simulation and human systems. Next one, what is a system? A system is defined as a group of objects that are joined together in some regular interaction of independence towards the accomplishment of some process. Example, production system manufacturing for automobiles. In this, we are having as a example for production control system. In this, you are having 4 types of department. One is purchasing department and fabrication department, assembly department and shipping department. These whole department comes under one thing, that is a production control system. And this is how a system is defined. A system is a group of objects which are connected in a one group. It is called as a system. And next one is what is a continuous system and a discrete system. You know that the continuous system will be having a continuous flow of signals in a certain time. For example, flow of water in a dam. And next one is a discrete system, is one in which the state variable changes only at the discrete set of point of a time. For example, server waiting for a customer to serve. In this thing, the server is always waiting. When the customer is coming, only he will be giving the service. Otherwise, he will be in rest position. That whenever the customer came, that will be taken as a discrete point in the discrete system. This is one example for this. And next one, in the system, what are the components of system? In components of system, we are having 5 types. One is entity, attributes, activity, and state of the system and event. First of all, what is an entity? An entity is an object of interest in a system. And attributes is an attribute denote the properties of the system. What are the properties is going on? That and all comes under that system. Next one is an activity, and any process occurring changes in system is called as activity. Next one is a state of the system. The state of the system is defined as the collection of variables necessary to describe the system at any time, relative to the objective of studies. In other words, state of the system means description of all the entities, attributes, and activities as they exit at one point in the time. Next one is event. An event is defined as the instantaneous occurrence that maybe changes the state of the system. And here we are having a separate example for the components of system and their entities. Here we have taken a system as a bank. That in bank, what are the entities? The entity is a customer, is the entity for the bank. And what are the attributes? Is the checking of account balance by the customer is an attribute. And what are the activity may be done? The activity described making deposit and withdrawing is the activity done by the customer in a bank. That is activity. Next one is what are the events occur in a bank? That event is customer arrival and departure will be calculated as a that thing. State variable. What is the state variable? In state variable, number of busy tellers and number of customers waiting in a queue, that will be comes under state of the system. What are the state? If it is customer is coming higher, means the busy tellers will so all be increased. If the customer is less, means that the tellers will be less. And here there is a note: a state variable may be changes continuously at over time, or they may be changes only at the discrete set of point, like in the discrete system. Next one is what is a model? A model is defined as a representation of a system for studying the system. Here we are having a 7 type of model. One is mathematical or physical model. Next one is statics model. Next one is dynamical model. And next one is deterministic model. And next one is pseudostatic model. And next one is discrete model. And the last one is continuous model. First of all, what is a mathematical model? A mathematical model uses symbolic notations and the mathematical equations to represent a system is called as mathematical model or a physical model. And next one is a statistic model. It is a representation of a system at a particular point of time and also known as MC simulation. That is a statistic model. And next one is a dynamic model. Representation systems as they changes at over time. For example, simulation of a bank, that is a dynamic model. Next one is your deterministic model. Constraint no random variables. They have a known set of input which will be resulted in a unique set of output. For example, arrival of patients to the dentist at the set of scheduled appointment time. That is a deterministic model. Next one is a pseudostatic model. Has one or more random variables as an input, and the random input leads to random output. For example, simulation of a bank includes random inter-arrival and service time. Next one is your continuous model. The continuous model, you will be seeing that in a continuous system, it will be continuously, it will be like a sinusoidal wave. It will be represented as a signals. And next one is your discrete model. It will be as a sampling and holding circuit. It will be a set of discrete points we will be stating in the discrete model. And next you are going to see about what are the steps in a simulation study you will be finding out. In simulation studies, we are having 12 set of steps. First step is problem formulation, set of objectives and overall project plan, model configuration, data collection, data translation, verified, validate, experimental design, production run and analysis, more runs, documentation and reporting and implementation. And we will be seeing this is a theoretical representation. What are the problem formulations and what are the set of objectives we will be seeing. First of all, we will be seeing what is the problem formulation. If you want to do any problem, any simulation for any problem, First, you should describe the problem, what is the problem and what are the set of data you have to going to give that you should be want to be delivered to your program list or that analyst list. After that, you are going to set the objective for your plan and overall project plan, whether it is more number of people involving or it will be what is the steady cost will be there and what are the required number of results will be there. That and all you will be in taking the steps in the second step, that is setting of objective and overall plan will be project plan will be executed in step 2. Next one is your model conception. What are the abstracts and what are the selections and what are the assumptions and what are the enriched models you are stabilizing. That and all you will be modeling in the model conception data. And after that, in data collection, you will be studying what are the data required for simulation. That will be you will be collecting the data in the fourth step. Next, you will be translating the data into models in a real world process. You will be translating the data according to your software or your simulation language that you will be converting. And next one is after converting, you will be verifying whether the data and the performance and the verification are correct and the logic and all correct, and you will be verified. And next one, you will be validating the discrete set of iterative process, and also you will be checking the models and you will be calibrating all the things. And next one is your experimental design. You will be constructing a experimental design and you will be calculating what are the experimental design you will be taking and what are the length of the installation periods and what are the length of simulation run and how many replication will be needed. That and all you will be stating in the simulation design of a experimental design. And next one is your product run and analysis. There are used to be estimate the measurement of performance of the system that are being simulated. You will be doing in the product run and analysis. You will be running the simulation and you will be analyzing whether it is to your thing. And more run based on the analysis of run that have to be completed. The analysis determine the if additional run are needed and what design those additional experiments should be followed in the more run. After that, if the simulation is completed, you will be taking the set of documentation and reporting work. In documentation and reporting, that the documentation is divided into two types. One is program documentation and progress documentation. You will be validating the what are the program documents and what are the process document. You will be certifying that in what are the process you will be using and what are the final report you will be taking for a certification. That and all you will be taking in the documentation and reporting thing. And next one is your 12th one is implementing. After doing all types of simulation, you will be implementing the set of steps, whether if you are changing anything. And here we are given a set of simulation model buildings can be broken into 4 phases. One is phase 1, phase 2, phase 3 and phase 4. If you are having any updation after the thing means, then also you can, if step 1 and step 2, if it is you are want to change anything means, that phase 1 will be you can be able to modulate, and in phase 2 you can change the data in 3 and 4, 5 and 6 and 7th step, and in phase 3 you can be consist of 8th, 9th and 10th step. You will be evaluating all the things, and in 4th step you will be doing the documentation and reporting, and after that you will be doing the implementation. If it is not required, you will be continuously doing the state of simulation in the studies. This is a flow diagram of our studies. In flow diagram, you can see just first one is your problem formulation. If you are setting a problem formulation, you have to explain to your program list, and after you have to set the objectives and overall plan, and you have to calculate, you have to construct the model of the configuration, and you have to collect the data. If both the thing is satisfied, you will be going for a model translation with the collected data, and after that you will be verifying. If the verification, if a verification is okay, means you will be going for validation. If the validation is not your up to your appointment, you will be then you will be going for again for model translation, and you will be constraining some data, and you will be again going for verification. After that verification, you will be going for validation. If the validation is okay, means you will be going for experimental design. Otherwise, you will be, if you want to change anything, means if it is not okay for validation, means you will be changing the model configuration data, and you will be also changing the data collection, and you will be recording more and more data, and you will be again going for model translation data, and you will be verifying that, and you will be then you will be validating the things. After validating all the things, you will be constructing your experimental design, and if the experimental design is okay, and the product and the run and the analysis will be done. If the analysis is okay, means you will be going for more run. If the analysis is not okay, means you will be going for a product run and analysis with the given data. If it the data is not required, if not needed, if you want to go for another experimental design, you will be going for experimental design, and you will be changing all the things, and again you will be coming to the product run and analysis data, and after that you will be going for more run. If all condition is okay and your more run is also okay, means you will be going for documentation and reporting, and after documentation and reporting, you will be implementing the all steps in a one thing. That is called, that is moral. This is the steps in simulation. And next one is your simulation of an event. In simulation of the event, you will be having a queuing system. A queuing system is described by it is calling population, the nature of the arrival, the service mechanisms, the system capacity, and the queuing discipline. In this, you will be seeing the two types of system. One is single server queuing system. Another one is double server queuing system or two server queuing system. And you will be knowing what is the calling population. The calling population is the source of customer to this queuing system, and it can be either infinity or finite. That is called as calling population. See here in this diagram you are given that is a calling population. You are having a server. The calling population will be required in, take example for a banking system. In a banking system, the calling population will be a customer, and the server will be there. If from the calling population, if they want to going for a depositing amount, they will be going in a deposit counters. If they want to going for withdrawing, they will be going for withdrawing counters. After if customer coming for depositing as well as withdrawing, first you will be going for whether the server, which server is free, means that they will go and finish their work. After that, they will be coming to again in calling population, and after that they will going for next step. These are the steps you will be calling for in a single server queue. In example of single server queue, you will be you will be having a single server that you will be describing in next step. Here you have taken a single server queuing system. Here we are taking as a one example, a small grocery store has only one checkout counter. That means it is having only one server. Customer arrival at this checkout counter at the random of 1 to 8 minutes apart, and each possible value of inter-arrival time has been a same probability of occurrence. The service time varies from 1 to 6 with the probability shown in the table below. We will be seeing that, and the problem is to analyze the system by the system simulating the arrival and the service of 6 customers we have to take. Here we have having a simulation servicing time with ranges from 1 to 6, and we have been taken already the probability have been given. If not, probability is not given, means you will be calculating the probability with the representation of your 1 by 6 means you will be dividing 1 by 6 and you will be taking the probability and you will be doing the accumulated probability in this thing. And you have to calculate the certain 7 step. What are the certain 7 step means? You're going to calculate the average waiting time of a customer and probability that a customer have to be waiting in a queue, and the idle time of the server, and the average service time, and the average time between the arrival, and the average waiting time of the who are waiting in the queue, and the average time a customer spend in a system. That and all you're going to calculate in this 7 step. After that, here you have given a sequence of random numbers in random digits for arrival time and service time also. Here we have given as a 6 random digits, and assume that the first customer arrived at the 0 point. They are saying to assume that the first customer arrival time should be 0. Okay, wow. Then you will be calculating the arrival and service time and getting the random. Here they have for arrival time they have been not given, but the service time they have been given, so that for arrival time you will be taking that it will be from 1 to 8 means you will be taking 1 divided by 8 is you will be getting 0.125. So you will be taking the probability like 0.12 for all that 8 service time arrival minutes, and you will be taking a cumulative probability and will be taking, and after that you have to take the random digit assignment. That will be from which here we have seen that the customer arrival should be you should be taken as 0. So we are starting from 0. Instead of digits you should be converted into decimal, that numerals. That will be taking for first time you will be taking 0 to 125. After finishing 125 you will be taking starting from 126 to see in second cumulative that will be ending at 250. So you will be ending at 250. After that you will be starting from 251. Same as that you will be calculating all this thing, that duration, from duration, and when you are stopping, from that you have to start the another thing. Like that you will be starting this. Same service time also you will be taking a probability. This probability have been given. If not given, you have to calculate it by yourself by taking 1 divided by 6 means you will be having some set of points, and you have to do some accumulative probabilities, and you have to random digit assignment also you should take. That it will be starting from here. This service time is they have told only arrival time should be taken as 0. For service time you can take from 1 also. Otherwise you want to take 0 also you can take, but initially we are taking that is the 1 to 10. It is stopping by 10, so you will be starting by 11 to 30 because it is ending in the cumulative probability. It is 30. So 30, and next one is 31 to 60, 61 to 85, 86 to 95, 96 to 100. That we can take. And next you have to determine the time between the arrival and the service time. So we will be taking the customer, 6 customer, and what is the random digit for your arrival, and we will be taking the for service time also. Here we have told that first random digit for first thing is you will be going to take us, you should be taking, and that is a 0. So you are taking the random digit 0. You will be taking this value and putting which have been given in the random digit for your arrival time, and famous you will be taking for this random digit for your that service time. How you should take this? I will be each one. I will be taking the first thing. For first customer, it is 0, and it is this also becomes 0. For second customer, that is random digit is 913, and you have to go to this is the arrival thing. So you go to the arrival timetable 915. Okay, you can see this. Where is that 915 falls on this thing? Arrival timetable means that will be falling on 876 to 1000. That will be falling on the time between the arrival is 8. So you will be taking that is an 8. Like that you will be taking for that values you will be taking for inter time between the arrival minutes, and same as you will be taking for here the first customer is 84. Okay, well, so in this the 84 means where will be 84 falls on this service time means random digit assignment. It will be falls on this 61 to 85. 84 falls on 61 to 85 means that will be in equal to that the service time is 4. So we are taking 4. Same as that you will be calculating all the things, and we will be taking the what are the things, and we will be calculating, and service time also we will be calculating all the things, and we will be taking the steps, and which the customer is arriving or going, and what are the service time begins and what are the service time ends. We will be calculating this one. After calculating, we will be finding the arrival time by how you will be calculating arrival waiting time is the total time customer waiting in a queue is 3. The only a single customer if have been waited in a queue according to this calculation. So we will be taking as 3 by total number of customers is 6. So we will be taking 3 by 6, that is 0.5 minutes. The average waiting time for a single customer is 0.5. Next one, you will be calculating a probability of the customer has to wait in a system is Q is equal to number of customer by number of customer waiting in a queue and number of customer by that thing. That is 1 by 1 customer only waiting in a queue. So 1 by total number of customers 6. You'll be taking that the digit will be 0.166. In terms of percentage, you will be calculating 16.6. And the idle time of the server means the server idle time is you will be calculating here, that is 12. So we will be taking that is a 12, and the total run time of the system also we will be calculating. See here the total run time is 30. So we will be taking 12 by 30, that is comes under 0.4. In terms of percentage, it will be 40%. And next one is your arrival service time, that is will be your total service time by total number of customers. The total number of customers is 6, and total service time you will be calculating here. This is has given us 18, so that you will be taking 18 by 6, that is 3 minutes the average service time. Average time between the arrival if you will be taking by sum of the time between the arrival and number of arrival by 1. You will be taking that sum of the time between the arrival is we will be taking, that is 26. See, arrival is 26. So that you will be taking 26 by 6 minus 1, you will be taking 26 by 5, that is equal to 5.2 minutes. And next we will be calculating the average waiting time for those who are waiting in a system is, so only one customer will be waiting, so we will be taking a 3 by 6, that will be a total time of customer waiting in a queue, and the number of customers is it will be equal 3 minutes. And next one, average time spent in a system in the system is total number of customers spent in a system is 21 by 6. Number of customers is 6. So your average time customers spend in a system is 3.5 minutes. And with this we will be concluding our lecture, and next lecture we will be seeing the second unit. What are the random digits and what are the random generations and all we will be able to see in the second unit. And thank you for watching this video. Thank you.